Hello, everybody. Welcome, everyone. My name is Balázs Bézi. I'm Scrum Master for the platform teams. And today we are going to have a sprint review product update for the protocol teams. We are planning this session for 1 hour, and please feel free to raise your questions, give us feedback in the live chat below. Also, please make sure that we will understand at the very end when we will get back to those questions. So please include the context of that question too. All right. Let me start the slideshow and give it to Dima.
Hi, everyone. My name is Dmitry. I'm software engineer at Tenderdash team. Well, for the past sprint, we planned to work on implementation same block execution and on a tendermean backport. Probably this is kind of last backport which we did before. And now also we had a couple of unplanned tasks. Well, let me go through them. Yeah, let's start from the same block execution. Same block execution is an improvement that led us to increase performance of our system, Tenderdash, and reduce resources consumption. Well, the current approach is next block execution. That means we always need to wait for the next block in order to confirm that our state was changed. With the same block execution, we don't need to do it anymore. So yeah, we kind of, the outcome of this task is to get at least two kind of critical things for our platform. And currently we refactored state component. It was rewritten completely. And now we have begun work on stabilizing the code base, which has been affected by our refactoring. And we estimate that it will take one sprint or probably 1.5, I don't know. Backport status is in review. Tendermean code migrated, conflict resolved, test fixed, and the next update will be after Lukasz, my teammate, will return after holidays. About two unplanned tasks. The first is about investigation issue on testnet. The problem was the Tenderdash got stuck and couldn't reach a consent quorum. We released a hotfix that helped resolve one issue, but after that we identified another problem on testnet, which is not related to Tendermean, but yeah, it's probably was 3 issues at the same time, and this is the reason why it was quite difficult to identify the kind of our problem. Well, currently testnet is working kind of stable, and we hope with a new release, Tenderdash and the platform will fix a lot of bunch of issues which we had before. Well, also I worked on small update for CI workflow, which should give us to create Docker image using just to adding the label to a PR, because current approach doesn't allow us to do it. But sometimes we need to create our release without our kind of normal flow for releasing of application. For instance, for the local development, somebody in protocol team, or probably if we need to deliver something quite quickly on DevNet or testnet even. Yeah, it would be nice to have this option for us. Well, next one, what will be in this sprint? I think we continue working. I'm not think it definitely true. So we continue working on stabilizing same block execution. And yeah, and finalize the backport. As I already mentioned, to finalize backport, we need to wait for Lukasz. So I think I've done.
All right, thank you very much.
Yeah, welcome.
I'll give it to Grovedb.
Hey guys. My name is Wisdom, software engineer on the Grovedb team. For this sprint, the plan was worst case cost and efficient references. And I'll go into more details on the next slide. Okay, so while working on worst case cost, we realized an inefficiency with insertion of references. So before, when you insert a reference, you have to go all the way to the base of the reference chain, as you have to follow all the references up to the base and then hash that node in order to get the value hash for the reference. This was unnecessary for the most part because of that information was already in the immediate node in the chain. So we worked on an optimization that basically reduced the worst case cost by a very large factor in certain cases. Then we also worked on efficient references. So this basically allows the reference size to be really small depending on what you are trying to do. So before, all references were absolute paths, and sometimes you might have a reference pointing to an item beside it, and you do not need an absolute path for that. You can just say the next guy beside me is who I'm pointing to. So efficient references allows you to be able to make statements like this. So you can point with very, very succinct information to whatever item it is that you want to point to. So this was merged today, so that is cool also. So I'll pass it on to Sam to talk about the rest of the slide.
Yeah, thanks, Wisdom. So I'm Sam, CTO at Dashcore Group, but helping out on Grovedb code for the last sprint. I do want to say one thing about efficient references and how cool it is. Efficient references will allow us to dramatically reduce costs on platform. Basically, because before, if you had like a reference in your tree and it was saying, oh, go into the documents side, go, so it'd say, go into the documents tree, go to this contract, and then to this element in the contract. With the efficient references, we can just say, go to up, 3 spots, and then down to the element. It sometimes saves like 80% in space, or even more. It can save a ridiculous amount of space. So it's very, very, very nice that we now have it, and it's great that Wisdom did that so quickly. Well done. So now I'm going to talk about sum trees. Sum trees are actually an idea that came up on Discord. A little backstory. People were worried about inflationary bugs that could happen in platform. This was coming off a hack, I think 4 weeks ago, or yeah, 3-4 weeks ago, where some chain lost. There was some issue, some type of way was broken. So the idea behind sum trees, and I'll present it more in depth probably when it's merged in 2 weeks, is that if you think of a normal Merkle tree, you have a left element and a right element. And the reason why the Merkle tree or the Merkleized tree is verifiable is because the left element and the right, well, and people are looking, it's the opposite, but you hash the node here, you hash the node here, and you combine those hashes and you move it upwards in the tree, and then you can basically verify the authenticity of any element in the tree. There are many, just if anybody wants to know more, type in Google Merkle tree, and there's a lot of write-up on how Merkle tree works. But what we're doing with sum trees is we're not only Merkleizing it, but we're also saying that you add the value in the left and the right of the tree. And this feature, I don't know if it's ever really been done before. So we basically combined the ability to have a verifiable tree, which is a Merk tree, with the aggregation of value, which basically comes from adding left and right. And think about what this could mean. It basically is, if we use this on a balance tree, the root of the tree for the balance would be equal to the total amount of value in platform on a low level at all times, meaning that inflationary issues could never happen. And this is why I added it to the roadmap, is because nobody wants platform to have any issues, like inflationary issues. There's a lot of new code. So we really want to make sure that it's secure 100%. So there really can't be an inflationary bug. So we can basically use the sum trees on all the balances of the identities, on multiple parts of the payout of the withdrawals that we did before, and then basically the sum of all things everywhere will be the total value held in platform, and it has to match the amount of credits added to platform. And if the two values don't match, well, then we just halt the chain. And halting the chain is not great, but it doesn't allow anybody to withdraw money from platform that didn't exist. So I think that will be a very cool feature. Moving on to worst case costs. So we've been talking about worst case costs for quite some time, and I wanted to spend a little bit more time explaining what exactly is going on and why it's so hard. We've been working on costs and then worst case costs, then we paused it, and now, it's me and Wisdom are working on it full stop. I'm not sure exactly the word I'm trying to find. So as Wisdom said before, we've done inserts. What we still have to do are updates and deletes, and they're quite hard. We've been working on batches as well. Generally, the biggest problem is that there was just a lot of things that needed to be changed because of lower level improvements in the storage. For example, we saw, this is just one random example, looking into the way RocksDB works, the value and the key length, the length of those values are actually stored as a variant. And we hadn't been seeing that they were a variant, so we were trying to figure out what the discrepancy between the worst case and the actual were. So we figured that one out, but we've been figuring out tons of low-level costs for the last sprint. So let's move on to the next slide. I wanted to take a moment to talk about what the cost of an operation in Grovedb is, and explain a little bit how the fee system works. When you create a state transition, let's say it inserts things, it deletes things, it updates things, it is summed up to a structure that contains the following elements. How many times storage syncs were done, which is stored in a seek count. How much was written to the database, which is storage written bytes. How much was updated on the database, which is storage updated bytes. How much was loaded from the database, storage loaded bytes. How much was freed. I think people understand it's basically deleted. And how many times we called the hash function. We use Blake3. So once let's say you do an insert, well, an insert will not free anything, but an insert will definitely write data. It will update bytes for all the nodes that are above the insert. It will have to load the data for the updated nodes, and it will do many seeks on disk to figure it out. And when we get back the operation, the operation cost in Drive, what we do is we multiply each value here times a number to get a cost in Dash. And then that cost in Dash is how much people pay for the state transition. Now, the worst case cost, to explain it just a little bit more, touch on it, applies to before the operation is actually executed. It's verified that it can enter the mempool, and it just basically does a small check. And during that check, it does a quick calculation of the worst case cost. The worst case cost should be similar to the cost of the operation, or like not too much higher. And then that allows it, if the identity has enough value, has enough credits, then the operation is allowed to proceed. And let's say somebody has, 1,000 duffs in their account, and the operation's worst case cost is 900. Well, they have enough, and then in the end, the cost will probably be, let's say, 800. So they get charged 800, but they can only have the operation go through if they have enough for the worst case cost of it. Okay, cool. Let's move on. Another cool thing that I found while in the weeds this week, we were using hash map. We don't use hash maps that often. Most of the time we use a B-tree map. For many, this won't really be obvious what the difference is. A hash map allows for a much quicker lookup versus a B-tree map. And basically, underneath, I explained why. A hash map, the insertion best time is 1, and the worst case is n being the amount of elements in the tree. For a B-tree map, it's log n for the best case, and the worst case is also log n. So it's always deterministic for a B-tree map how long it's going to take, whereas the hash map, it's not. So what was realized this sprint was that somebody could attack the system in a specific way, creating a certain series of transitions that would cause hashes to go exactly in the worst case of a hash map. And for that reason, we switched to a B-tree map everywhere. Now, if we look, this is basically a diagram right here where I was trying to figure out why this was happening. And basically, we see like one value that was inserted caused a, I don't know, maybe times 100 times worse performance compared to the normal case for the hash function. And this is because there was a collision, a random collision. So yeah, hope that's understandable for some people. Okay, let's go next slide. So what's next? We're going to continue on worst case costs in Grovedb. We're going to finish the batches. We're going to do updates, and we're going to do deletes. And then pretty much that's it for Grovedb worst case costs. So hopefully we can make good progress there. Batches have come a far way. and they might be done, but it's really hard to know for sure until we have updates working. And deletes. So then we're also going to do tree references. Tree references allow for a reference that we, a database reference, to point to a tree instead of pointing to an item. And this allows people to do queries on the underlying elements of a reference, which is a lot more powerful than it sounds. And the way I'm explaining it probably doesn't do it justice. For now, people have to believe me when I say it's very cool. We'll show a demo once we have tree references. And let's go on to SDK. Thank you very much.
Thank you very much.
Hey everyone, I had turned my camera off because the internet connection not super great.
All right.
So okay, for the sprint we had a goal to we actually continue reworking chain synchronization, and this sprint was mostly dedicated to writing tests. On previous sprint review we had 15% for both unit and integration tests, and now we have around 75 and 65. This includes 3 packages. We have 3 affected packages: Wallet Library, DAPI Client, and Dash SPV. So this is it mostly, and we could follow to what's next. Next is consensus rule fine-tuning for Dashmate, testnet, and devnets. QA, and also peer review, and finalizing of the integration and unit tests. This is it. Thank you.
Thank you very much. Let's see the protocol team. Kostya?
Yeah, hi everyone. My name is Kostya. So the main goal for this sprint was to release V23 to the testnet. But worst case scenario predictions in Grovedb are not ready yet, so fee calculation is not ready in the platform. That's why it's still in progress. So about protocol tasks. As you know, modern browsers are moving towards security, and they prefer HTTPS over HTTP. And since we support both Node.js and browser environments, we were needed to add SSL support to our Dashmate tool. So we added SSL support to Envoy. And right now we need to add support to DAPI client as well, both for JSON RPC and gRPC protocols. Yeah, and we updated Envoy to the latest version since we used pretty outdated version that is not supported already. And I pass my torch to Ivan.
Thanks. We accomplished this sprint actually, withdrawal transitions implementation in Rust TPP. So it's the first part of the three tasks to implement withdrawals. So it's basically the closing the circle when you can emit some platform credits, locking the Dash on payment chain, and then you can withdraw back credits to Dash. So first part is implementation of state transitions and protocol part, which is done. Now we're already working on the processing of the state transitions in the drive. So every block we can get this pending withdrawals and create special transactions for payment chain, which should be signed. It actually will be the third part. It will be signed by LNQ, by long-living master quorum, so we can broadcast it back to the payment chain and move funds to the specific address. Yeah, so we're somewhere in the middle. Also, we worked on the stabilizing new platform version 23. Functionality-wise is almost complete. The only part which is missed is our fee calculation, and we are waiting for our colleagues in Grovedb team, and they're doing great progress. So I hope next sprint we'll have something at least to test. But we continue to test the existing functionality, and we covered several bugs. Actually, it's pretty lots. I counted like 17 pull requests today with bug fixes that we merged in. Some of them provide pretty nice improvements and will be important for our incubator devs. For example, we found the issue that's on local network. We used actually only one node from 3 existing that we're running. So performance for local network should be better now. And there are some issues related to the fee pool functionality. We also disabled the extra block what Tendermint produced by default, or if you change the state to provide signature for the block, the previous block. That's how the next block execution work, our current scheme in Tendermint. But since we are moving to the same block execution, and Dima Golubov already explained today, was the difference. So we won't need this extra block anymore. So we reduce the load on the network and load on the nodes. To require less resources. Yeah, and we started to work on BLS binding for the actually for Rust binding. We have a BLS signature library from Chia network. We have a fork with our modifications, and we use this library in our core blockchain to create the threshold signatures. We use it in the platform as well. But since the new standard IETF was released, we want to switch to the version 2, which is standardized. So we need to create the bindings for the new version as well. And now we're working on the binding for Rust, what we need in our new ported components. Yeah. Next slide, please. Yeah, thanks, Balash. Yeah, in the next sprint, we will continue to work on this system. We'll continue to work on the withdrawals, what I just described, the processing and the pending withdrawals, and next task is the signing of the withdrawal transactions. We're going to continue to work on the Rust binding for BLS signatures library, and to work on the HTTP for DAPI implementation, what was described today. And of course, we'll continue to test platform 23 on DevNet. And yeah, from now on, it looks pretty stable at this moment. So yeah, that's our plan. More like continuation of our work that we started this sprint.
All
Thank you,
right, thank
Balázs.
you. Thank you very much. And let's see the Rust port update. Pavel.
Hello, guys. My name is Pavel. I'm today, instead of Anton, will share with you the details related to the Rust port. So yeah, before I start on the overall status, I think it's good to explain to you guys, really high level why we're doing this. So well, I'm gonna start with just a very high level explanation. Maybe for each of you, it's very obvious, but for those of you who are basically are not in the loop, what's going on with that could be pretty useful. So, well, the blockchain basically introduces authorization, right? And it's to the applications, and more precisely authorization for which is out of the box and allows the other application developers to use that authorization to enter the world. We usually call this digital economy, right? I mean, when it comes to the digital economy, you usually make some transactions, buying something, selling something, and sometimes you expect to have a proof that you own something. And obviously, if it comes to transactions like this, money is involved, right? So if money is involved, so basically we expect things to go, when we wake up in the morning, we expect that the money we spend another day will be still there, right? So it's quite important to overall system, and which based on the blockchain should be really highly reliable, right? To make us sleep without worrying about losing our money. So if the overall blockchain technology is highly proved in terms of how things are work, and it proves that we cannot modify the data easily, this sometimes doesn't apply to the implementation of the blockchain protocol, because there are two different things. Because the blockchain protocol is something that is already have a good quality, but also we expect the same level of quality from implementation of blockchain protocol, which is also a platform. Therefore, all these features, like about how high quality, high availability, security, right? Making sure that new updates are kind of safe from perspective of the overall health of the network and doesn't destroy the overall network is extremely important, right? Because nobody wants to lose the money. So those things actually are, I've mentioned, are kind of really difficult to accomplish in JavaScript, because historically JavaScript, it's not the kind of language you usually use for writing super consistent applications. So on the other side, we have a Rust, right, which has been designed more or less specifically for this kind of task, which comes with great compiler, which is super strict and conservative, which prevents developers from making bugs, right? And security. It comes with a great security out of the box as well, and also great performance. So, well, the overall efforts in our writing Rust is actually to make sure that direct user will be very confident about using and putting money in our network, right? To not afraid, they shouldn't afraid that, well, they someday may lose some money or anything that is valuable for them. Okay, so what we're doing in that direction. So first step we're doing is rewriting the protocol, which is first stage in our roadmap. And the overall rewriting of the protocol can be split in 3 parts or tiers. The first tier is actually rewriting the changes or protocol in version 22. The second tier is porting the changes from the protocol in version 23 to version 22. And the last tier is about merging or incorporating the Rust protocol implementation of protocol in Rust into the existing ecosystem in JavaScript. So technically, all these tiers can be done in parallel, but not exactly as I explained in a couple of seconds. So, well, this is the first year, right? I mean, first year, this chart, what you're seeing now, shows the progress on migrating the features or porting or rewriting the protocol in version 22. As you can see, we made kind of significant progress in that direction and in that area. It was because actually because while we were working on porting changes from version 23, we encountered some dependencies on unported changes from version 22. So most of our sprint we spent on the unblocking the tier 2 by working on task from tier 1. So this is actually the progress, and this is something that we spend most of the sprint. So if you can go to the next slide, we see that, well, technically the changes to porting the changes from version 23 has been put on hold for a while, but the good sign is that we actually now we are unblocked, and we can spend our efforts on migrating the changes from protocol in version 23, and it's very unlikely will be blocked again. So additionally to porting the changes, we are also making our efforts towards incorporating the currently existing Rust version of the protocol into the ecosystem of the JavaScript. This actually, just two tasks actually are not very trivial as well, and it wasn't expected even to be finished in this sprint because they are kind of expensive and requires a lot of planning and the testing and comparing the API to every single detail, and addressing all differences between JavaScript version of the protocol and the Rust version of the protocol. So, well, all these activities actually are time-consuming. So, in spite of all of this, we will in the next sprint will continuing work on all these three activities, and we hope we will come with significant progress or even finishing some part of it. So yeah, I think that's all for me.
All right, thank you. Thank you very much, Pavel, for this comprehensive update. All right, let's jump into the questions. As far as I see, there is only one question unanswered, which is, will the Dash roadmap be updated on Dash website? All right.
Sorry, I was muted.
Please go ahead, Sam.
Yes. The question was, when will it be, or will it be?
Will it be?
Yes, it will be. It's reviewed by the head of product every few weeks.
So it should be updated soon.
Yes. Basically.
All right. Thank you very much. All right. I see no other unanswered question in the chat. And then I would like to wrap it up. Thanks everybody for joining to this session. If you have any feedback, comments, let us know in some form, in some way or another, on social media, Discord. Yeah, help us with those feedbacks. Thank you for your attention, and see you in